Hello students, welcome to Indian School of Chemistry. Today I came up with another video on organic chemistry, and today we are going to cover about Beckmann's rearrangement. All of you have must read about the rearrangement of carbocation, where primary aim of rearrangement is to attain more stability. Here it is a different type of rearrangement where we'll discuss why such kind of rearrangement takes place. So first, let me overview about what is Beckmann's rearrangement. So Beckmann's rearrangement is basically conversion of an oxime. This compound you can notice oxime, which is when treated with either a H plus catalyst or some more reagent like this can be taken, which we'll discuss in the later half of this video, is converted into an amide. So you can notice that the reactant and product are isomers. Here simply a rearrangement has taken place. Another important thing is since it is an oxime, it can show geometrical isomerism across C double bond. Here restricted rotation is there. And for geometrical isomerism, lone pair is considered as a different valency. So in first case, you can see that OH and R1 are anti to each other, where in the next case, OH and R2 are anti to each other. And you can notice in terms of rearrangement, the product is also different. When R1 is anti to OH, then R1 is connected to NH group. And when R2 is anti to the OH group, R2 is connected to the OH group. This is the basic difference. So the two different geometrical isomers shows different products in the rearrangement. That's why it is a beautiful concept. So let me overview first about the concepts quickly. So if we have two different groups that could migrate, then two possible geometrical isomers are formed of unsymmetrical oxime, because if we have an unsymmetrical oxime, then it is two geometrical isomers. One is cis, another is trans, which you can say syn and anti also. When the mixture of geometrical isomers of oximes are rearranged, it will form mixture of product. As I have shown you earlier, if R1 and R2 are different, two different products are formed. And it is very interesting to note that the ratio of the products in the mixture is exactly the ratio of geometrical isomers. Like if the reaction of a carbonyl compound with hydroxyl ion produces oxime, so in the ratio, the ratio in which oximes are formed, the rearrangement product is also in the similar ratio. And the most important part of this rearrangement is that here the group which is trans to OH group, or you can say anti to the OH group, will migrate. This is very important thing. You know that in rearrangements, a group migrates to get another configuration. In this rearrangement, the OH group, the group which is trans to the OH group will migrate. This is the important one. Here, my order of migratory aptitude is not applicable, which you may have read in different type of rearrangements. In Beckmann's rearrangement, order of migratory aptitude is not applicable. Here, the group which is anti to OH group will only migrate. So first we'll discuss about the mechanism, and then I'll come to the conclusion why this rearrangement has taken place. So first look at the point, here we have an OH group in which carbon is sp3 hybridized, and this nitrogen is basically sp2 hybridized. So you can see attack has taken from oxygen to H plus. Mostly it has been done by nitrogen. You know nitrogen is better nucleophilic character than oxygen, but since S character of nitrogen is more than that of oxygen, that's why attack is preferred from oxygen. Be careful. In the rest part of organic chemistry, you have read attack always preferred from nitrogen side, but there nitrogen and oxygen both are sp3 hybridized, then nitrogen is better donor. Since here nitrogen hybridization is sp2, which has more S character, that's why attack of nitrogen is difficult than the attack of oxygen. So once oxygen is attacked on H plus, then what will happen? It will form OH2 plus, which becomes a good leaving group. Then deficiency is coming on nitrogen. Now come to a very important conclusion which you must know about Beckmann's rearrangement or rearrangement of this type. Earlier in the rearrangement of carbocation, all of you have read that the primary aim of rearrangement is to attain more stability. Here the logic is if a element which is more electronegative than carbon, let's say here nitrogen. If we have an element more electronegative than carbon, here it is nitrogen, gets deficiency or it is going to get deficiency. Since water will leave, deficiency will come on nitrogen. Then a group from the adjacent carbon migrates to shift the deficiency from nitrogen to carbon. You can see in this reaction, plus charge has moved to carbon, not to nitrogen. So principle primary aim of this rearrangement is deficiency shifts from more electronegative element to carbon. and it will happen in many of the rearrangements. So you can make it a rule for organic chemistry. Whenever you feel like the electron deficiency is about to come on a more electronegative element than carbon, then from adjacent carbon a group will migrate in an intramolecular manner to shift the deficiency from nitrogen to carbon. The same thing happened here. And as I've already told you, in Beckmann's rearrangement, the only group which is anti to OH group will migrate instead of this R2. So here migratory aptitude order is not preferred. Here the group which is anti to OH group will migrate. With the migration, deficiency moves to carbon. Then the water molecule, which was formed in the during this reaction, has attacked on this carbocation, and then it has formed another product where water has attacked as a nucleophile on carbocation. Further, we get a compound which can show tautomerism, and it gets enolized, or better to say tautomerized, and then we get a product as amide. So you can notice the group which is anti to OH group will migrate to nitrogen. That's why it has bonded with nitrogen. Reverse of this, we have showed you in the first example itself. When R2 was anti to OH, then R2 will come up with nitrogen. So two different products are formed with two different geometrical isomers. This is the basic function of Beckmann's rearrangement. So now if I sum up the thing, I said when a more electronegative element than carbon is expected to get deficiency, then migration takes place from the adjacent carbon in the intramolecular manner. Notice it very carefully, intramolecular manner, and the deficiency shifts to carbon. This is the primary aim. In Beckmann's rearrangement, order of migratory aptitude is not applicable. You can notice this thing. Order of migratory aptitude is not applicable. Notice it carefully, not applicable. Okay. And here the group which is anti to the OH group will migrate. This is the important aspect. The group which is anti to the OH group will migrate. This is the another important point which you should notice about Beckmann's rearrangement. And reactant and products are the functional isomers. As I have already told you, reactant is oxime and product is amide. Beckmann's reagent is catalyzed by acid, as I have already told you, but there are some more reagents which can promote this reaction, in which you can see tosyl chloride, SOCl2, PCl5, PCl3, P4O10, sometimes tertiary amine, NaOH even, and sometimes this silicate type of compound, silicon derivatives. So CH3 Si type compounds are also acts as a catalyst or promoting the Beckmann's rearrangement. Okay. Now we come to the problems to understand the same concept. This is the first problem. As you know, in most of the videos, I'm covering up the concept with three problems. And as you'll see, every next problem is better than the previous one to make your concept more clear. So this is the first problem which we are discussing. So from compound A, hydroxylamine has reacted. We have formed a compound B. Then H2SO4 is added. We got compound C, and then compound C has heated up at 533 Kelvin to 545 Kelvin with water. We found a compound nylon 6, which is a polymer. So you can see in this question, polymerization is added. Now you can see this is a trend to create a good problems even in the JEE advanced paper. तो आप सब समझते हो इस बात को कि अगर हमें कोई चैलेंजिंग प्रॉब्लम क्रिएट करनी हो तो बस क्या करना है, रिवर्स ऑर्डर में पूछो. एवरी वन ऑफ यू नो ए टू जेड अगर मैं किसी से पूछूं तो एक मिनट में ए टू जेड आप सुनाओगे, बट मैं रिवर्स पूछूं अब जेड से ए सुना तो इट बिकम्स अ डिफिकल्ट प्रॉब्लम. तो जे एडवांस के पेपर में भी सेम ट्रिक अप्लाई करते हैं. नॉर्मली हम लोग ऑर्गेनिक रिएक्शंस को रिएक्टेंट से प्रोडक्ट की तरफ पढ़ते हैं, बट डिफिकल्ट केस में आईआईटी वाले क्या करते हैं, प्रोडक्ट दे देते हैं और रिएक्टेंट पूछते हैं. सो आई हैव फ्रेम्ड द क्वेश्चन इन सिमिलर मैनर फॉलोइंग द सेम ट्रेंड. तो ये बहुत कॉमन ट्रिक है, किसी भी सवाल को डिफिकल्ट करना हो, रिएक्टेंट से प्रोडक्ट पूछने के बजाय प्रोडक्ट से रिएक्टेंट पूछिए. सो दिस इज वन ऑफ द प्रॉब्लम ऑफ दैट टाइप. एंड एज यू ऑल नो कि जे एडवांस के पेपर में मोस्टली कंसेप्ट मिक्सिंग होती है. अभी मैं स्टार्टिंग में आपको ऑर्गेनिक में ऑर्गेनिक मिक्सिंग या इनऑर्गेनिक में इनऑर्गेनिक मिक्सिंग या फिजिकल में फिजिकल मिक्सिंग करके ही क्वेश्चन दे रहा हूँ. Later, in my successive videos, you will see we'll mix physical with organic, organic with inorganic, which is the recent trend of JEE advanced paper. आप 2022, 23, 24 के एडवांस के पेपर्स देखोगे तो आपको ये चीज कॉमन ट्रेंड में दिखेगी. उन्होंने ऑर्गेनिक के क्वेश्चन में फिजिकल इनकॉर्पोरेट किया होगा. लास्ट टाइम SN2 का क्वेश्चन आया था ऑर्गेनिक का, और उसमें केमिकल काइनेटिक्स ठीक ठाक इन्वॉल्व कराई थी. एंड लाइकवाइज लास्ट टाइम थर्मोडायनेमिक्स का एक क्वेश्चन आया था, उसमें बायोमोलिक्यूल बहुत इन्वॉल्व किया था, स्पेशली डीएनए स्ट्रक्चर. तो ये कॉमन ट्रेंड है JEE एडवांस का. तो अभी मैं इनिशियल वीडियोस में आपको इनऑर्गेनिक, ऑर्गेनिक और फिजिकल को एक्सक्लूसिव कर रहा हूँ, बट when I'll start my courses, and you'll see there it is a beautiful mixing of physical, organic, and non-organic. So in this question, what I have done, polymerization is included in Beckmann's rearrangement. So first of all, you should know nylon 6. So might be possible अभी आप लोगों ने polymers उतना अच्छे से revise ना किया हो. So for your hint, I'm giving you some extra information also so that polymerization भी यहीं थोड़ा सा revise हो जाए. जो लोग learn करना चाहते हैं वो अगर थोड़ा सा यहीं से चीज़ों को learn करते चलेंगे, so it becomes more easier for you to prepare like even polymers. So since it is given C is the monomer of nylon 6, so it is caprolactam. And for your help, I have taken directly NCERT line. So caprolactam is basically this compound, which when treated with heated at 533 Kelvin to 545 Kelvin of water, we got nylon 6. Nylon 6 is a polymer and it is used for the manufacturing of tire cord, fabrics and ropes. So it's a very important polymer. कुछ लोग जो पॉलीमर्स जानते होंगे उनको थोड़ा आइडिया होगा कि पॉलीमर्स के नॉमेनक्लेचर में या स्पेशली अमाइड्स के पॉलीमर्स के केस में हम जो टर्म लिखते हैं सिक्स, जैसे लिखा है नाइलॉन के नॉमेनक्लेचर में वी हैव यूज्ड टर्म नाइलॉन 6. वन मोर पॉलीमर यू हैव दैट नाइलॉन 6 6, नाइलॉन 2 6. ऐसे नाइलॉन के पॉलीमर्स में हम लोग बेसिकली एक नंबर लिखते हैं. सो दिस नंबर एक्चुअली रिप्रेजेंट्स द नंबर ऑफ कार्बन इन द मोनोमर यूनिट. सो नाइलॉन 6 लिखा हुआ है तो देखो इसके मोनोमर में 6 कार्बन होंगे. यू कैन इजीली काउंट. These are the 6 carbon in the monomer unit. That's why it is called nylon 6. Okay. तो ये मैंने आपको क्वेश्चन में हिंट कर दिया, बट आप जानते हो फाइनल एग्जाम में जब ये क्वेश्चन आएगा तो आपको नाइलॉन 6 के बारे में नहीं बताया जाएगा, बिकॉज दैट इज एडिशनली इन योर कोर्स इन द फॉर्म ऑफ पॉलीमराइजेशन और पॉलीमर्स. तो आपने पढ़ा रखा होगा. अभी मैंने को इसलिए हेल्प करा बिकॉज सम ऑफ यू विल नॉट बी इन टच ऑफ पॉलीमर्स, सो मैंने उसके आपको क्वेश्चन के हिंट के फॉर्म में बता दिया. सो सी इज मोनोमर ऑफ नाइलॉन 6 विच इज कैप्रोलेक्टम. कैप्रोलेक्टम स्ट्रक्चर मैंने बताया. अब आप देखो आसानी से प्रेडिक्ट कर सकते हो. इन कैप्रोलेक्टम यू कैन सी लाइक व्हाट्स द बॉन्ड, NHCO बॉन्ड. तो आपके दिमाग में अमाइड वाला बॉन्ड क्लिक कर रहा है. एंड नाउ नोटिस द क्वेश्चन, हमने बी से सी बनाने के लिए H2SO4 यूज किया, सो इट इज H प्लस कैटलिस्ट. और उसके पहले देखो NH2OH दिख रहा है, तो दैट मींस हाइड्रोक्सिल अमाइन वाली रिएक्शन हो रही है, विच इज द रिएक्शन ऑफ अमोनिया अमोनिया डेरिवेटिव रिएक्शन. एल्डिहाइड्स कीटोन्स में आपने सबने पढ़ा होगा. सो अब आपको आसानी से समझ में आ जाएगा बी क्या है. एक ऑक्साइन, दिस वन. और इसमें अगर हम H प्लस ऐड करेंगे तो बैकमैन्स रीअरेंजमेंट से ये कार्बोलेक्टम बनेगा. आप सब आसानी से मैकेनिज्म देख सकते हो. इसमें तो एंटी वाला ग्रुप भी नहीं देखना पड़ेगा, बिकॉज डबल बॉन्ड सी डबल बॉन्ड एन के अक्रॉस अगर आप देखोगे तो बोथ साइड इट इज सिमेट्रिकल. सो एनी ग्रुप यू कैन माइग्रेट. सो कार्बन रिंग जो है वो एक्सटेंड करके 6 मेंबर से 7 मेंबर में कन्वर्ट हो जाएगी. एंड बिकॉज ऑफ दैट यू विल गेट दिस एज योर फाइनल आंसर, जिसमें आप कैप्रोलेक्टम इजिली प्रिडिक्ट कर सकते हो. दिस इज कैप्रोलेक्टम. बैकमेन्स रीअरेंजमेंट आप बहुत आसानी से अप्लाई कर लोगे. और अब इसके पीछे वाला स्टेप जो है वो कैप्रोलेक्टम बनाने से पहले जो रिएक्टेंट है उससे हमने कैसे बनाया था, हाइड्रोक्सिल अमाइन के रिएक्शन से. सो दैट इज बीन डन विद साइक्लोहेक्सेनोन. दिस इज द इनिशियल रिएक्टेंट साइक्लोहेक्सेनोन. सो साइक्लोहेक्सेनोन की रिएक्शन अगर हम कराते हैं विद हाइड्रोक्सिल अमाइन, सो दिस रिएक्शन इज बेसिकली अमोनिया अमोनिया डेरिवेटिव रिएक्शन. जो आप में से ज्यादातर लोग समझते हो, इट इज न्यूक्लियोफिलिक एडिशन फॉलोड बाय एलिमिनेशन मैकेनिज्म. अगर मैकेनिज्म का पार्ट नहीं उतना क्लियर है तो आई कवर अप इन सम सक्सेसिव वीडियोस, या जब हम लोग एल्डिहाइड कीटोन के लेक्चर्स पुट करेंगे तब आप इस चीज को और अच्छे से समझ सकते हो. अदरवाइज यू कैन गो थ्रू योर नोट्स. बहुत कॉमन है, ज्यादातर टीचर्स बहुत अच्छे से पढ़ाते हैं. सो इट इज द रिएक्शन ऑफ, इवन बोर्ड्स का भी बहुत इंपॉर्टेंट पार्ट है, अमोनिया अमोनिया डेरिवेटिव रिएक्शन. सो दिस इज न्यूक्लियोफिलिक एडिशन फॉलोड बाय एलिमिनेशन. एल्डिहाइड कीटोन्स की कॉमन रिएक्शन है न्यूक्लियोफिलिक एडिशन रिएक्शन, बट अमोनिया अमोनिया डेरिवेटिव्स के साथ इसमें एलिमिनेशन में परफॉर्म होता है. सो रिएक्शन इज न्यूक्लियोफिलिक एडिशन फॉलोड बाय एलिमिनेशन. सो हाइड्रोक्सिल अमाइन के रिएक्शन से हमारा आसानी से ऑक्साइन बन जाएगा. सो यू कैन इजीली गो थ्रू विद द आंसर ऑफ द क्वेश्चन. सो नाउ योर ए इज साइक्लोहेक्सेनोन एंड अकॉर्डिंगली बी एंड सी आप आसानी से प्रेडिक्ट कर सकते हो. सी मैंने आपको बताया कैप्रोलेक्टम है, जो हमने नाइलॉन 6 पॉलीमर के हिंट से पिक करा. ओके, नाउ मूव टू द नेक्स्ट क्वेश्चन. दिस क्वेश्चन आई हैव बेसिकली लिंक्ड विद chemistry in everyday life. I know that is also a chapter like which is not done with most of the teachers in a proper format. So I'll give you the hint for the question. Don't worry. So the question is, we have a compound P which is treated with AC2O with HF. We got Q. Q is treated with NH2OH. So now you can all can see the pattern. हाइड्रोक्सिल अमाइन यूज करके हम ऑक्साइन फॉर्म करेंगे और ऑक्साइन के बाद बैकमेन्स रीअरेंजमेंट करा के एक्चुअल प्रोडक्ट में कन्वर्ट करेंगे. तो प्रोडक्ट में देखो उसने दे रखा है N 4 हाइड्रोक्सिल फिनाइल इथेनामाइड. So amide is given, that's why you can easily predict it is Beckmann's rearrangement. And this compound is known as paracetamol, which is an analgesic and antipyretic. Some of you may be aware of the fact analgesic is a like drug जो pain killer या pain remover के काम आता है. And antipyretic is a drug which is used to reduce the like fever. So I mentioned that thing as an hint for you. In your question, you have to identify P, Q, R, and S. So analgesics reduces your pain and antipyretics reduces fever. And N4 hydroxyl phenylethanamide, if you draw the structure, this is known as paracetamol. For you, I have drawn the structure. This is paracetamol. Now you can initiate the question. Since we know paracetamol is treated with SOCl2, so this is also a trick of the question. Mostly in Beckmann's rearrangement, we use H plus, but for this question, we have used SOCl2. So, like as I have already told you that we can use SOCl2, docile chloride, and many other reagents, which we have discussed in the earlier part of the question. If you missed that, just go through with that part, and then you'll easily understand with SOCl2 we have performed Beckmann's rearrangement. Paracetamol is amide, so definitely you all can understand that R will be certainly an oxime. Oxime to amide conversion is Beckmann's rearrangement. And then at that oxime hit is also from the previous part of the question where Q has treated and formed R and S. You can easily notice that if it is given R and S, that means R and S will be geometrical isomers. And you know in case of geometrical isomerism, in Beckmann's rearrangement, two different products are formed. So if R is asked exclusively, that means you have to predict which geometrical isomer is the answer. Okay, so let me proceed for the question. Now, R as I have taken, OH and this phenol ring is in the anti position. So when SOCl2 is used for Beckmann's rearrangement, you know that the group which is anti to OH will be migrated. SOCl2 will accept for H plus from the O2 plus. Just a minute. So all of you are like, in this case, oxygen lone pair of electron will attack from to vacant orbital of this sulfur. So this SOCl2 part will be added up over here. Then this will be eliminated and carbocation will be formed. And to this carbocation, when water will attack, it will form OH2 plus thing again. And then again we remove H plus. It will form, and you can say a tautomeric form, which gets tautomerized and it will form paracetamol. So steps are very simple, just like Beckmann's rearrangement earlier. Only thing is you have to notice that here phenolic linkage is anti to OH group. So that group has come up with NH group. So since in paracetamol with NH group we have phenolic linkage, that's why in the structure of R we have taken this phenolic linkage in the anti position. Now you have to find S. So certainly it is geometrical isomer, which we have replaced now. So S, in case of S, the CH3 is anti to OH group. They are geometrical isomers, so R and S are easily predicted. Then if we have to start with S, it will react with SOCl2 and Beckmann's rearrangement will take place. So this product will be formed. So you can easily notice in this case, since CH3 is anti to the OH group, so if CH3 is anti to the OH group, then CH3 will bond with NH group. And if you compare this product with paracetamol, so it will be metamer of paracetamol because around NHCO group, we have changed the valencies. If they are swiped, if phenolic linkage is bonded with NH group, that is paracetamol. If CH3 link is bonded with NH group, it's not paracetamol, it's metamer of paracetamol. So, like if a person will create a different type of question, it can be linked with isomerism also. At the moment, I have restricted my question to just chemistry and everyday life part 2 Beckmann's rearrangement only because we are discussing primarily Beckmann's rearrangement. So certain modifications can be done in the question to create a better problem or even more difficult problem with respect to J advanced. Now in case of Q, it is very easy. Like you know, it is reaction of hydroxylamine with Q to get R and S. So for that, we have to take a ketone in which one valency is phenolic linkage, another one is CH3. And before that, since P is there, which is treated with AC2O, AC2O, I hope all of you can understand it is basically acetic anhydride. So acetic anhydride is attacking with H plus catalyst on phenolic linkage. So at para position, COCH3 can be added in the phenol. So since it is Q, so P will be certainly phenol. I hope it is clear to all of you. If you are feeling difficulty, you just go through the problem again. It is like self-explainable. I have explained each and every point very carefully. So you'll definitely understand. Now come to a more tricky problem. This is the third question which we are going to discuss. So in this question, you can say in the following reaction sequence, X is treated with hydroxylamine, we got Y is treated with H2SO4 forms Z, and then Z is treated with S3O plus followed by heat, we got P and Q. And the question is given that P is a carboxylic acid and Q is an amine. So it is clear-cut hint when P is a carboxylic acid, Q is amine. That means Z is certainly amide. And once Z is amide with H plus it is treated, so Y will be certainly an oxime. And that is also a clear hint from X to Y is reaction of hydroxylamine. So it will certainly create oxime. So that means X will be a certainly carbonyl compound. Okay. And as I have already told you, like it is a clear-cut pattern of difficult problems of JEE bars that they'll always ask question in terms of given product to reactant. And in this question, you can see like neither reactant nor product is given. So we have to take the help of options here. So you can see in the first option, it's given Y is this is structure in which Q is lesser basic than pyridine. So you can see here GOC part has also involved in the question. So you can see like with Beckmann's rearrangement, how many options are there. We have taken some help of like GOC, we have used isomerism, we have used like polymerization, we have used some chemistry and life. So multiple concepts can be incorporated with a single concept of Beckmann's rearrangement. That's why it's a very beautiful case where advanced people can create good questions and definitely a new question can be created. So I'm giving you multiple types of hints or multiple types of ideas to discuss about Beckmann's rearrangement so that you can definitely face a new problem also in a very easier manner. So you have to just read out the pattern of the questions, uh, and that will be definitely helpful to understand a new problem also, because you all know that in JEE was mostly a new problems there. So in this case also, like once you can see that Y is given a compound which is oxime, and with respect to OH, NT is over here pH. So if NT is here pH, then amide form will be PHNH. So PHNH will create amine as pyridine, amine as aniline. So it is given Q is lesser basic than pyridine. So you all know that aniline is lesser basic than pyridine. And another part you can see here what we have done. In the next part, you can see that with respect to OH, the anti group is now cyclohexane group. This one, anti part is cyclohexane, this one group. So if cyclohexane is there and if it has gone through Beckmann's rearrangement, then it will form C6H, this cyclohexane NH2. So that will be certainly more basic than pyridine because it will be an aliphatic amide. For X, it is given PHCO this group. So definitely with Y, you can see like there will be definitely two valencies for the ketone, which forms oxime, or two different geometrical isomers has formed. So this can be X. We'll discuss little later. And Y and Z are functional isomers. So you all know that Y and Z are formed by basically Beckmann's rearrangement. So they will be certainly functional isomers. Now we'll solve the question in proper form. So let's say I have taken now X with respect to options. I have got a clear-cut hint that X is the given compound. So I'm starting with the same. If options will not match, then we have to think something more about X. So here X is PHCO and this cyclohexane ring. And hydroxylamine has taken, so it is ammonia-ammonia derivative reaction. Oxime will be formed and two different geometrical isomers are possible in which across C double bond and one time cyclohexane ring is N2 to this OH group. Another time this benzene ring is Nt to this OH group. Once you add H plus to both of the like reactant, you will definitely get different products. And in the starting itself, I have told you that the yield of the product is in the same proportion to the yield of the geometrical isomers. So with respect to yield, there is not much changes. So all of you can see like if in this reactant, this OH is anti to this cyclohexane ring. So this cyclohexane will come up with NH group. And in this case, this OH is anti to this phenyl ring. So this NH will come out with phenyl ring. So these are the two amides formed in the like Beckmann's rearrangement. More mechanism part I haven't used because I'm dealing with the third question. Two times I've already explained the mechanism. If you have confusion, you can see starting part of this video where we have explained the mechanism properly. And then if you do the hydrolysis, so since they are amide, they'll be hydrolyzed to a amine and a carboxylic acid. So this is the carboxylic acid formed and this is the amine. And the question it has given clearly that your Q is amine and P is carboxylic acid. So if we have the first reaction sequence, then this will be P and this will be Q. If it is second half of the question, then this will be P and this will be Q. And now in the question is given if Q is lesser basic than pyridine. So if Q is lesser basic than pyridine, then we have two options for Q. Either it is aniline or it is NH2 group bonded with cyclohexane ring. So pyridine, then Q, if Q is lesser basic than pyridine, then Q will be certainly aniline. And if Q is aniline, then we'll reverse the question the same format. Then Z will be this compound in which pH is bonded with NH group. And if this is Z, then Y will be certainly where pH is Nt2H2, which we have discussed in the starting of the question. So for the final examination, you need not to write that much. I'm writing so much so that you can understand the problem easily. Otherwise, with the discussion of problem itself, I've explained you the solution. And now in the second half, it's given if Q is more basic than pyridine. If Q is more basic than pyridine, then it will be an aliphatic amine, because you know all aliphatic amines are more basic, because here nitrogen will be sp3 hybridized. Nitrogen will be sp3 hybridized, whereas in pyridine it will be sp2 hybridized. So definitely more S character means lesser basic. So pyridine is lesser basic than Q, or Q is more basic than pyridine. It's the same thing. So once this is Q, then Z, in case of Z, what will happen? NH group will be bonded to the cyclohexane ring, and then Y will be the compound where OH will be anti to the cyclohexane. So now you can clearly see that if Y and Z will compare, these are the two possibilities of Y and Z. So Y is an oxime and Z is an amide. And the starting itself, I have told you that for Beckmann's rearrangement, reactant and products are functional isomers. So that is also a part of this question. So all of you can see like oxime and amide will be functional isomer. So for this question, all the four options were correct. So answer for the question is A, B, C, D. So it can be a good multiple choice question. I hope you like the video, and keep sharing, keep watching. Thank you so much. And there is one important announcement also, like Indian School of Chemistry is announcing their JEE Advanced course for 2025 students, and it is going to start in February. It will like cover up complete all important concept of JEE Advanced courses, and the duration of the course will be from February to May 2025. And it will contain 35 live sessions of 2 hours each, in which we'll cover up most of the important concept of JEE Advanced, and be a part of it. Thank you so much.